Hello everyone, welcome to my class. In previous lecture, we have learned about process life cycle, process creation, program execution, process status monitoring, and process termination. Today, I'm going to talk about signals in more detail. We will learn what is signals, what types of signal are there, who send a signal to a process, what happens to the process when it receives a signal. Especially, it is important when the process is terminated. Generally, a process may terminate in two methods. One is normal termination, the other is abnormal termination. More specifically, the process can terminate normally using underbar exit system call or exit library function. The other is abnormal termination. The process can be terminated by the delivery of a signal. What is a signal? A signal is a notification to a process that an event has occurred. Who sends a signal to a process? The first one process can send a signal to another process. This is for inter-process communication. The second one, the kernel can send a signal to a process or processes. Why does the kernel send a signal to the process? One of the events have occurred on your system. The events include hardware exception, software exception, and user interrupt. Due to these signals, the child process may be terminated abnormally. Okay, read the slide once again to review the concept of signal, the types of events, and who sends a signal to a process. User interrupt may be invoked by typing Ctrl+C or Ctrl+Z or Ctrl+D on the keyboard. A signal is a unique integer starting from signal number 1. It is defined in signal header file. SIGXXXXXX is the format of signal name. For example, like signal interrupt, it starts with SIG, and signal interrupt is the signal's symbolic names. There are two categories of signals. One is the traditional or standard signals. The other is real-time signals. The traditional or standard signals are used by the kernel to notify processes of events. They are numbered from 1 to 31 on Linux. This table shows the standard signals on Linux. You can see the signal name, signal number, description, and default actions. Term means termination. Core means core dumps. For example, let's see the signal interrupt. Its name is signal interrupt. Its number is 2. It means terminal interrupt. Its default action is termination. When the user types the Ctrl+C on the keyboard, the terminal driver sends the signal to the foreground process group. The default action for this signal is to terminate the process. Next, this table shows signal number 15 to 28. And next, this table shows signal number 29 to 31. For more information, refer to the link. This page shows the overview of signals. Linux supports both POSIX reliable signals, hereinafter standard signals, and POSIX real-time signals. You can see the meaning of term, ignore, core, stop, continue. You can see the sending a signal, waiting for a signal to be caught, synchronously accepting a signal, signal mask and pending signals, standard signals. The second column of the table indicates which standard specified the signal. P1990 indicates that the signal is described the original POSIX 1-1990 standard. P2001 indicates that the signal was added in SAS version 2 and POSIX 1-2001. You can see the signal numbering for standard signals and real-time signals, interruption of system calls and library functions by signal handlers, interruption of system calls and library functions by stop signals. What happens to the process when it receives a signal? The process performs one of the following default actions depending on the signals. Case 1, the process is terminated. It is referred to as abnormal termination. Case 2, a core dump file is generated and the process is terminated. Core dump means the scanned image of the virtual memory of the process. It can be loaded into a debugger in order to inspect the state of the process. That is to say, we can take a look at the state of the process using core dump files. Case 3, the process is stopped. Stopped means the execution of the process is suspended. Case 4, the process is resumed. Resumed means the execution of the process is restarted. Sending a signal. A sending process uses kill system call to send a signal to a receiving process. The kernel sends a signal to a process. Instead of accepting the default actions for the signal, the process can change one of the following actions. This is called setting the disposition of the signal. Case 1. The default action is restarted. Case 2. The signal is ignored. Case 3. The signal handler is executed. Generally, the kernel can send a signal to a process or processes when an event is occurred on your system, including hardware exception, software exception, and user interrupt. There are two methods to set the disposition of the signal. One is to use signal system call. The other is to use signal action system call. Signal system call is the original API for setting the disposition of the signal. However, signal action system call is a more preferred API than signal system call because of the portability issues. Following the signal or signal action system call, the kernel calls the signal handler. The signal handler is a function written by the programmer that performs proper tasks in the response to the delivery of a signal. Actually, everything can be included in the signal handler. The term signal set and signal mask appears a lot for operating a process. Signal set in a group of signals that are to be blocked by a process. A process won't block three signals: signal child, signal interrupt, signal quit. This is called signal set. On the other hand, signal mask is currently a set of blocked signals. In the right picture, the signal mask is empty. Signal interrupt signal is delivered to a process, and then signal interrupt signal is added to the signal mask because it is included in the signal set. There are several signal-related system calls. To initialize a signal set, you can use signal empty set system call. To add signals to a signal set, you can use signal add set system call. To change the process signal mask, you can use signal proc mask system call. To find out the existing signal mask, you can use signal proc mask system call. To change the signal dispositions, you can use signal or signal action system call. To send a signal, you can use kill system call. To wait for a signal, you can use pause system call. Let's see the manual pages on the signal-related system calls. This is practice time. Practice makes perfect. In this time, we will implement a new program named myShare command with signal disposition using signal-related system calls, including signal action, signal empty set, signal add set, and signal plug mask system call. This picture shows the overall procedure. We will describe this picture once again. Step 1. Parent process uses fork system call to request I want a child process to the kernel. Step 2. The kernel responds, OK, I will create a child process for you. The kernel makes the memory space for the child process, similar to the memory structure of parent process. Step 3. The child process uses exec library function to request I want to be a new program named share command to the kernel. Step 4. The kernel responds, OK, I will find out the program you want and load the new program into memory and replace the existing child process with a new program. Now, the child process becomes the new program named myShare command. Its new life begins. Step 5. As usual, the parent process uses wait system call to obtain the status of the child process from the process status buffer. This is possible because the kernel stores the status of the process in the process status buffer. Step 6. An event is occurred. The kernel sends a signal to the process. Step 7. The child process uses signal action system call to the signal disposition. Step 8. The kernel calls signal handler. OK, until now, I described the overall procedure of myShare command with signal disposition. From now on, we'll implement the program using Visual Studio Code.